Welcome to this video on the Doppler effect. The Doppler effect explains how frequency changes when there is motion between a source and an observer. This is a fundamental concept in wave physics that you experience in everyday life. Think about an ambulance or police car speeding past you with its siren on. As it approaches, the siren sounds higher in pitch. Then, as it passes by and moves away, the pitch suddenly drops and sounds lower. This familiar experience is the Doppler effect in action. The Doppler effect is defined as the change in frequency or pitch of a wave when there is relative motion between the source of the wave and the observer. The key word here is relative motion. Either the source can be moving, the observer can be moving, or both can be moving. What matters is the motion between them. When a sound source moves toward you, the sound waves get compressed together. The waves bunch up in front of the moving source. On the other hand, when the source moves away from you, the waves get stretched out. They spread apart behind the moving source. This compression and stretching is what causes the frequency change. Let's understand what happens to the frequency. When the source is approaching, the compressed waves mean more wave crests reach your ear per second. This results in a higher frequency, which you hear as a higher pitch. When the source is receding or moving away, the stretched waves mean fewer wave crests reach your ear per second. This results in a lower frequency, which you hear as a lower pitch. The Doppler effect can be described mathematically. The observed frequency, f prime, equals the source frequency f, multiplied by the quantity v plus or minus v sub o, all divided by the quantity v minus or plus v sub s here. F prime is the observed frequency, f is the source frequency, v is the speed of sound, v sub o is the observer's velocity, and v sub s is the source velocity. The plus and minus signs depend on the direction of motion. The Doppler effect appears in many real-world situations. Emergency vehicle sirens are the most common example. Train horns passing by stations also demonstrate this effect. Aircraft flying overhead produce a noticeable pitch change. Race cars zooming past on a track show the same phenomenon. In all these cases, motion causes an apparent change in frequency. Let's review the key points. First, motion creates relative changes in wave frequency between a source and observer. Second, approaching sources produce higher frequencies and sound higher in pitch. Third, receding sources produce lower frequencies and sound lower in pitch. Fourth, the Doppler effect applies to all types of waves, including sound waves, light waves, and more. Understanding this effect helps explain many phenomena in physics and astronomy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.